All right, so everyone, I would like to introduce Daniel Jenkins. Jenkins? I just realized
Yes.
I don't
Yeah.
know. Jenkins, yes, okay. Daniel Jenkins is a postdoc at Vanderbilt University and also the executive director of the Slave Society's Digital Archive, so SSDA. He did his graduate work at Vanderbilt and also studied the early modern Atlantic world and completed his PhD in 2018. So this is Dr. Daniel Jenkins. He also spent the 2018-2019 academic year as a postdoctoral fellow in data curation for the Latin American and Caribbean Studies at Brown University's John Carter Brown Library before returning to Nashville in fall of 2019 to become the executive director of SSDA. So welcome, Daniel, and please, we're interested and excited to hear your presentation today.
Thank you, Cheryl. Thanks to you and Jesse and the rest of the DSI team, both for this invitation and also for all the work that y'all did to help get this project off the ground. I literally would not be here without you guys. So what I'm going to talk about today is the process that we have been working on to automate the extraction of information from our historical records. I'm going to start by very briefly explaining a little bit about what SSDA is. It is a collection of digital images from both secular documents, that is, notarial documents, government documents, and ecclesiastical documents, which are typically sacramental records recording things like baptisms, marriages, and burials from the Catholic Church from the late 1500s into the 20th century. As of spring 2021, there are more than 700,000 images in the collection that are publicly available, primarily from Latin America and the US, although we're also looking to expand out to Africa and really, any country that touches the Atlantic Ocean and was in some ways implicated in the transatlantic slave trade. And we have more images coming pretty frequently. Our work has been funded by the NEH, the ACLS, the Mellon Foundation, the British Library, as well as having been received generous internal funding from Vanderbilt, among others. And you can learn more at our website, on Twitter, or at the GitHub repo that I will share later in the presentation. So just to give you kind of an idea of what our work looks like, we send teams to places around the world. They work with local folks to digitize records, to preserve them, and also as kind of that image in the upper right-hand corner indicates, to literally these images are at risk due to climate change, instability, things like that. So this is both a preservation effort, and then what I'm going to talk about today, it's an effort to access the information that are held in these records that we have preserved. So, okay, we have a collection of a bunch of images of old books. So why is this an NLP problem? Why is this a machine learning problem? Why is this something that data science is interested in? So I want to preface this all by saying that preservation is critically important. The work that the project has done over the years to preserve these records is amazing and critical, but preservation alone doesn't guarantee that we can actually use these records. And that's, for me, that's the primary purpose, or part of the primary purpose of this project. It's not just to preserve them, it is to make them available to the world as well. So the reasons why preservation alone isn't enough, number one, these are documents written in early modern scripts, in foreign languages that aren't English, so they require specialized skills to read. Number two, the collection is very large, so if you only have like a name you're looking for, it can be difficult to weed through a few 100,000 images and find the person you're looking for. And finally, since all we have is images of these documents, we can't do things like make them accessible via screen readers. And also because some of these images are fairly large, it can be challenging for folks with limited internet bandwidth to use them. So there are accessibility concerns as well. So we could get around a lot of these problems by manually processing these records. I'm sorry. Here I am. It's okay. We could get around a lot of these problems by manually processing these records, but that's not really a viable solution at scale. For example, to manually transcribe an image is, very, very generously can be done in half an hour. It probably would take closer to an hour. And again, actually, combing through that transcription and picking out information about people, places, and events at least another half hour, right? And if you do the math on that, it's 350 years of full-time work to manually process our whole collection. So we're not going to be doing that. Even if we had the resources to do that, it's not an efficient use of anybody's time, right? So there are other ways to go about accessing the information encoded in these records. So all right, what do we do? Number one, we do have to manually transcribe some records for training data. So, earlier in the process, I put together a fairly simple markup standard for these transcriptions to give structure to them. And we produced a number of high quality manual transcriptions that look, I'm just gonna a brief glance at this, something like this, right? And this is literally just, a little bit of structure added to a transcription of all the baptismal entries in this one document. So, okay, we've got our transcriptions. Next, we do what we're really going to be focusing on today, which is the annotation, the NLP. So the first thing we have to do is to produce training data. We have to actually label these transcriptions, label the entities we want to extract. And so we use Prodigy for. We'll talk more about that in a minute. The second thing we have to do once we have those annotated transcriptions is use those to train a machine learning model. We do that using spaCy. Again, I'm going to talk a little bit more about that in a minute. And then finally, once we have output from spaCy, which is in the form of spans with labels attached to tokens from the transcription, we have to do something to transform those into a structured representation of the relationships between pieces of information in the documents. So, it's indicating that one person is the godparent of a child being baptized. The baptism is taking place on a certain date. To build out those relationships, we've actually done that using some pretty simple logic. Beyond that, once we have the model and we have the logic to finish the pipeline, we obviously will apply that full pipeline to all of our manual transcriptions. But then the real holy grail of this, and this I'm not going to be talking about today, but it's the broad sweep of the project, is having a handwritten text recognition solution to automatically produce transcriptions from all of our documents. So then we can use the workflow we developed on this smaller subset to process the entire collection. I'm very optimistic that's going to happen, and I hope that I'll be able to give this talk in a few years about how we did that part of it and process the whole collection. But what we're really going to focus on for these next 5 minutes or so here is the middle section, the annotation and the NLP. So we have annotated our records using Prodigy, which is not a free tool, but it's on the order of a few $100s for a small team license. It's totally worth it if you're going to annotate records at scale. The reason that it's worth it is that it's super easy to use. For example, this is a live Prodigy demo. We have here a baptismal entry. Don't worry if you can't read the Spanish. What we're going to do here is we have these 5 labels up here in the UI. Right now we're in person. We're going to grab every instance of a person's name that we see in here. Going to grab all the locations. I don't see any. Going to grab all the dates. Going to grab, this is just kind of our label for characteristic, just something about the person. And then any information about relationships, and we're done. So we processed that entry in 10 seconds or something. So even if we want to work through like a few hundred, even a few thousand entries this way, it's really quick. And as soon as we've done that, we can output a JSON file right out of Prodigy that is then ready to use with spaCy, which is the Python package that we've used for NLP. These tools are designed to work together. You don't have to use them together. You can use either one independently, but also they work very well together. One thing I do want to note, the current release of Prodigy is not updated to work with the most recent release of spaCy. So if you do want to use the 2 of them together, you have to use one or both of them in a virtual environment. It's not a big hoop to jump through, but just something to note if you start playing around with this and can't figure out why it's not working. So spaCy is a great free Python package for NLP. This is where the work with Shiro and Jesse and the rest of the DSI team really took place last year. They really helped us kind of build out the slightly customized infrastructure that we use to do this. I'm going to just very quickly give you kind of an example of what this looks like in practice. So this is all done in Jupyter. And this is just basically to show how quick it is. I'm not actually going to run the training loop because the training loop is not the quickest, but this is basically just converting all of our Prodigy output into a data frame. And then actually spaCy itself requires a slightly different format, and this is that format. And then it's just literally a question of, writing a function that performs a training loop and doing a training loop. It's not that hard to set up, and the version 3.0 of spaCy is amazing. Our model results have been really, really, really good. Even with the just a few thousand observations that we have, we're getting models with F scores upwards of 95 now. So it's good. It's a really powerful tool. Once we've trained a model, again, this is all just done in Python. Load the model up, parse the transcription of a given volume, and apply the model. This one I am going to run live just to show you that even applying this to a whole book doesn't really take long. This is going to take 10 or 15 or 20 seconds. I should have timed it out better so I knew exactly how long it would take, and I had the words timed up for it. But as soon as this is done, I'm just going to show you that it did in fact perform as advertised. It labeled people as people, and characteristics as characteristics, and dates as dates. This is not cherry picked. This is just the first few entries, and these entries are actually totally clean. It's not totally clean throughout, obviously, but these entries are good. So all right, once we're done with that, we have this giant pandas data frame, essentially, with a bunch of entities and spans associated with those entities. So the very last step is transforming those spans, that data frame, into a structured representation of all the relationships. This I'm not going to work through. It's just all the stuff that's going on behind the scenes. But what I am going to show you is all these functions in that one notebook applied to a whole volume, and do that live as well. This will take a second, but this is both applying the model to the transcription again, and then working through all the logic. And at the end of this, I'm going to let it run and show you what we get at the end of this. At the end of this, we get this JSON document, which is contains some basic metadata about the volume, the full transcription, and then the actual interesting part, which is all the people that appeared in the volume that were extracted, all the things we know about them. So all these characteristics were kind of attached to them using logic, and then all their relationships to other people in the volume. And then finally, all of the events. This is a baptismal record, so these are all the baptisms and births that are recorded in the book. Again, all structured, all connected. It's represented as JSON for now. I'm not exactly sure how we're going to end up serving this on the web. Haha, interesting, it broke. I don't know why that happened, and I'm not going to deal with that right now, but it shouldn't break. Trust me when I say that if I ran that code, it should actually produce that JSON document. All right, so this was a ton of information in a very short time, but the upshot of it is we have a pipeline for going from a manually created transcription of one of these volumes to a structured representation of the data that is contained in that volume, which is amazing. It's a huge step forward, and it's going to make this information so much more useful for researchers, for the general public who's just interested in learning more about the family history, because now they will be able to actually search the contents of these books, not just metadata about them. Most recently, Kai Malcolm, a wonderful undergrad RA in this project, has done some work to figure out if we have enough training data. I didn't really think we did, but his conclusion was we really do. Even when we combine all kinds of different kinds of records, so baptisms and burials and deaths combined together, documents in Spanish, documents in Portuguese, throw them all together, we actually, again, have models that have F scores in the 90s. So I think, we probably will continue to produce some training data, but we don't even necessarily need that much more. We will continue to fine tune the logic, including figuring out why it broke just then, hone controlled vocabularies, and just make it better, right? To make the output as good as possible. And then the next step is actually going to be to develop an API to hit all the data we make and then to share it on the web. And then the last step is the handwritten text recognition step, which is a little further down the road, but which will really unlock the entire contents of the archive. So that was a ton. Hopefully it was intelligible, but that is how we are using NLP and data science to unlock early modern historical records.
Daniel, that was so great. All we can do is virtually clap, sorry, but that was so great. And I see how like you've expanded some of the modeling that we've done since we did the project together. So it's cool to see you guys working on that. I see that there are some questions. Lee, did you want to unmute and ask, or would you like me just to read the question?
Oh, I just want to ask, I don't know this technique. So if this technique is to want to find some relationship between the history figures there in the transcript, so we don't need to see each page by ourselves, and we can send them to Martian and to find the relationship.
Yeah, so the way that really the way that we actually build out the relationships between the people is it's really simple. It's just based on proximity of words that are labeled in certain ways. Proximity of two names to a word that signifies some kind of relationship. We don't, once we have a machine readable transcription, we don't need the original image anymore. Depending on how the development of the HTR piece goes, there may even be a world in which before we develop the technology to fully develop transcriptions of images automatically, we can just, again, look for kind of key words in the images and use the same logic that we're using to build relationships now to build out like really key relationships without having full transcriptions, if that answered your question.
Yes, thank you.
And are there any more questions for Daniel?
Yeah, I actually have a question. I apologize, I came a little late, so you most definitely already said this, but what was that SSDA package you imported?
So the SSDA is actually the name of the project. It's the Slave Society Digital Archive, but one of the really great kind of workflow improvements that Shiro and Jesse helped us put together is using MBDev with our Jupyter notebooks. And what that basically means is, we've done this work, as we saw today, in a bunch of different notebooks, and we define functions in a bunch of different notebooks. But when you use MBDev, you can actually just import functions that you defined in other notebooks in the repo into whichever notebook in the repo you want to use those functions in. So when you see imports from SSDA, they're just imports from other functions we defined in other notebooks as part of this project.
Oh, okay, that's really cool. And what was that called? NBDev?
NBDev. Again,
Okay,
super easy to use, a little finicky in application sometimes. You have to get used to it, but once you're used to it, like I was doing unrelated work and I realized I can't actually work in Jupyter without NBDev anymore. So.
Okay, thank you.
Yeah.
Daniel, I just had to laugh at what you said because I'm the same way. Like once I started using NBDev, I was like, I can't do things without this package. It's so great.
Yeah, it's amazing.
All right, any more questions?
I have a last question. So is this method very accurate? So how do we check the results with the real world and the accuracy?
So that's a very good question. One of the things to do on the project board for this project is to build some quality checks. And so, part of the answer to that question is we can, there will be some entries that'll be processed in ways that are just obviously wrong, and that we can write logic to catch things that are just obviously wrong. There are some that are going to be some errors that are going to be a little more nuanced and more difficult to catch in an automatic way. I think, the way, once we actually really move this to production, and Jim is on this call, so I know that he has feelings about this. There'll be some degree of manual oversight, at least at the start, before we start sharing data at scale. I don't know that like we're going to have human eyes on literally every one of the thousands of entries that we're going to be wanting. I mean, thousands at first, and tens of thousands, hundreds of thousands, millions, hopefully eventually. But there will need to be some kind of automated quality checks, at least for really obvious errors. For example, one of the really funny things that I found just in this first volume is a baptismal entry where both the parents ended up being recorded as of the same gender, which is pretty unlikely in an early modern historical. I mean, not impossible, but then I went back and read the entry, and it was pretty clear that that was not the correct interpretation of the entry. So stuff like that we can catch in an automated way. And so I think a lot of the quality control, we just actually have to write the code to perform those checks.
All right, fantastic. Well, thank you so much for joining us today, Daniel. It's been great having you, and it was really cool to hear about the work that you've been doing. And I love the way that you guys are like assembling the entities now into like the actual familiar relationships. So I can't wait to hear from you again once the whole pipeline is in place and experiment with your interface. And thank you so much for coming.
Thanks, y'all. Thanks for having me.
All right, fantastic. So normally we would have demos, but I'm thinking that we're missing